Okay. So, welcome to this another course, that is power system engineering. So, first we will start this one with that overhead line insulators. Initially, particularly when we will cover your line insulators, overhead line insulators, as well as the cables. Initially, some theories will be there, and after that, as usual, a mathematical thing, it will be described and supported by a good number of examples. So, for this course, we will start with overhead insulators, right. So, first an hour or so, that only theories will be regarding this insulators will be explained. So, first thing is that generally that overhead line insulators are used to separate the conductors from each other, if you and from the supporting structures electrically. Now, you have seen the transmission line or transmission towers, where you will find that insulators are there. So, basically those high tension line, right, 66 kV or above, you will find those insulators are basically suspension type, and any other thing up to 33 kV level or even 66 kV level, pin type insulators generally they use. So, first we will give the description of this type of insulators, but it is a video lecture class. So, all these things something I have to skip, and whatever the basic things we will try to understand. So, first thing is that overhead line insulators are used to separate the conductors from each other and from the supporting structure electrically, right. While designing the insulator, the following considerations are made. I mean, whenever you choose insulator, then some consideration, I mean from the design point of view, right, you have to choose. First thing is, insulator should have a high permittivity, so that it can withstand high electrical stresses. So, insulator or what you call insulator material, whatever it will be used, it must have a very high your permittivity, right. And second thing is, the dielectric strength of the insulating material should be high, right. So, that means you have to design. Of course, later we will come, we will see that porcelain or toughened glass are the very common thing, but porcelain is mostly used, but later we will come, right. So, the insulator should be able to withstand over voltages due to lightning stroke, that lightning is a phenomenon, right, and switching or other causes under severe weather conditions. In addition to that, your normal working voltages, that means in insulator when it is designed, it should be able to sustain that the over voltages due to lightning stroke, due to switching or other causes severe other causes such as severe weather conditions during windy storms, right. And in addition to that, normal working voltage. Now, it should also possess high mechanical strength to bear the conductor under load, under worse loading condition. If you look at all the diagrams, other things, few I will show, all the diagrams, other thing cannot be shown in this video classes. But if you look at that high tension line, where you can see on the road side or in the it is passing through the high tension line, if you see the different way of insulators are placed, right. So, that means sometimes you can say vertically, sometimes you may say horizontal, and sometimes it is your V shape. We will come to that for brief explanation. So, it should possess high mechanical strength to bear the conductor load under worse loading condition. So, that means without insulator you cannot connect your transmission line to the tower, right. That is the thing, you have a tower, that is or sometimes we call poles or towers, and then cross arms will be there. So, once this is your it needs, and another thing is that it needs to have a high resistance to temperature changes. So, it has to have this thing, your resistance to temperature changes to reduce damages from power flashover. The flashover is very common, right. And second thing is, the leakage of current to earth should be minimum to keep the corona loss and radio interference within reasonable limit. This corona loss thing will come later. You have we will discuss corona loss also, but later. So, that will come after 3 or 4 chapters. So, that means that leakage of current to us should be minimum to keep the corona loss and radio interference within reasonable limits. Now, another thing is the insulator material, it should not be porous and should be impervious to gases in atmosphere and should be free from impurity and cracks which may lower the permittivity. That means, you have you have to choose the insulated material insulator material in such a fashion such that it should not be porous and should be impervious of gases in atmosphere, such that if where you are using insulators and if gaseous environment is there, then it should not be spoiled or damaged, right, and and should be free from impurity and cracks which may lower the permittivity. There should not be any cracks, right. So, the electrical failure of insulator occurs either by puncture or flashover. The puncture, if a puncture happens, that means that insulator will be totally damaged, right. So, that is why that your puncture case, in the case of a puncture, the arc passes through the body of the insulator and it becomes useless after the puncture, right. If any arc forms and it passes through the body of the insulator, then insulator will be totally damaged, and once puncture happens, although that phenomena is very rare, it happens, the probability of happening is very less, but still if it happens means that insulator will be totally damaged, right. And then flashover. Flashover is caused by an arc discharge between the conductor and earth through air surrounding the insulator. So, it is either due to line surges or due to the formation of wet conducting layer over the insulator surface. Normally, the insulator is not damaged by flashover. So, in the flashover, insulator will not be damaged because materials are designed, materials are made in such a fashion that flashover actually it does not spoil the insulator. You can see it in rainy season or other thing. Even if even on the traction line, those insulators, if it is there, particularly I have also observed during rainy season other things, some flashover is going on, but nothing will happen to the insulators. So, that is why flashover, if it happens, so insulator will not be damaged, but puncture, that means that arc will pass through the body of the insulator and it will be totally damaged. I will give you some diagram of it, right. Therefore, the sufficient thickness of material is provided in the insulator to prevent the puncture under surge condition. There is a strong possibility that under the surge condition that insulator your what you call maybe may got punctured, right. So, that means sufficient thickness of insulator material is used. Of course, these are all design parameters rather. So, flashovers are reduced by increasing resistance to leakage currents. The length of the leakage path is made large by constructing made large by constructing several layers called petticoat or rain shade. You might have seen insulator, I repeat this one, that flashover are reduced by increasing the resistance to leakage currents. The length of the leakage path is made large by your constructing several layers called petticoats or rain shade. You might have observed the insulator, it is like a cap type of thing, right. I will give the diagram later on. It is sometimes it is called petticoats or rain shade. That means, it will inner portion will remain dry, that is that your what you call the rain shades are used. They keep the inner surface relatively dry in wet weather condition and thus provide sufficient leakage resistance to prevent a flashover. So, that is the design thing. If you have seen the insulator, you will see that on the top it is a cap type of thing. I will come to the diagram later, right. So, another thing, these are all general thing. So, accumulation of dirt, then dust or salt or smoke etc. on insulator surface in polluted area is kept minimum, right, by providing semi-conducting glaze over the whole exposed surface of insulator. If you look at the insulator, you will see the top portion actually glazing, right. So, just to that your accumulation of dirt, dust or salt or smoke, all these things, there will be no there will be deposition will be less on the surface of the on the top portion of the insulator. That is why it is, you will find it is a semi-conducting glaze over the whole exposed surface of the insulator. But insulator made of porcelain and it is a very heavy, if one unit you cannot it is not easy to pull it by hand, it is very heavy thing, right. This reduces the surface deposition which may produce flashover at the operating voltage. Now, for satisfactory operation, the flashover should occur before puncture, right. This has to happen, that the flashover must occur before the puncture, but puncture I told you it is very rare phenomena, but if it happens, insulator will get damaged. So, ratio of the puncture voltage to flashover voltage, called the factor of safety, this is called factor of safety, is kept as high as possible. That means, puncture voltage should be much higher than the flashover voltage. So, therefore, the flashover voltage is reduced considerably by moisture and surface deposit. For satisfactory operation, the rain set should have the shapes like those of equipotential surfaces, and the insulator body should be constructed along the lines of electrostatic field around the pin. I will come to that. Around the pin means pin insulator, right. Also, the leakage resistance and capacitance of various rain sets should be approximately equal. So, the flux distribution, all these things. Now, actually before coming to the figure 1, this is actually figure 2, I will come to that. I have taken from a book, there rather than hand drawing. So, this is actually flux distribution of a pin insulator, this is a pin actually, and this is through insulator pin, and this is your lines of electrostatic field, and this is equipotential surface, and conductor is connected, suppose here, right. So, this is your line conductor. So, this is actually flux distribution of a pin insulator, and this one, that pin type insulator, this is actually this one, this is actually called rain shade, right. So, upper portion your what you call that inside of this, that will be more or less dry, and these are all cemented, but and this is actually pin, this is actually pin, this is here also 2 piece pin, this is actually pin, and this is actually screw, this is screw, I will come to that, right. And this is 1 piece, this is 2 piece, and this is 3 piece insulator. I mean 3 sets are there, or petticoats are there. This is 1, 2, 3. Here also 1, 2, and here also only one, right. I will come to that. So, generally, just hold on. So, now the types of insulator. So, neglecting the shackle type insulators used to support 400 to 30 volt, you might have seen in front of your house or in your college, that line insulators can be classified, shackle type will not consider, a small one, right. Either a pin type, B is also there, suspension type, and C is the strain or tension type, and D is equal to post type. So, a strain or tension type, pin type, suspension type, we will see how these are. So, pin insulator is supported on a forged steel pin or bolt, which is secured to the cross arm of the supporting structure. Actually here this is this is actually your pin, right, and what inside the screw is there, and these are cemented, and it is your what you call for supporting insulator here, that steel bolt or pin secured to a cross arm on the transmission pole used, right. In the transmission pole you have seen the tower and then the cross arm, right. So, cross arm of the transmission pole is used, right. To avoid porcelain directly engaging with a hard metal screw, use is made of lead or hemp, right. So, this is actually your what you call, to avoid emerging path with a hard metal screw, use is made of lead or hemp. So, this is actually your not fully been seen, but this is actually screw, and these are cemented made. So, it will be such that actually that screw is tightened to the cross arm, such that your what you call it, but it will not touch the insulating material, porcelain will not be touched, I will come to that, but that is why it is cemented, and with a metal screw uses are made of lead or hemp, generally lead, right. In case of lead, either of the following methods is possible. One is pin screwing into lead lined cement screw formed in the insulator. So, that is why it is cemented, it is cemented, here it is shown cement, right, cement it is, and this is pin. So, pin screwing into lead lined cement screw formed in the insulator. Second, another thing is a solid lead screw which is cast, cast on the head of the pin and secured direct into the porcelain. So, anyway, the conductor is attached to the insulator by tying it down with soft copper or aluminum binding wire depending upon conductor material. Actually, here these are the wire groups, here, right. If conductor passing through it, it will be suppose if it is a copper conductor, then it will be tied with your what you call by the copper same copper conductor. If it is aluminum, then it will be tied with aluminum conductor. So, this is actually wire groups. So, this is 1, 2, 3, this is 3 pin, this is 1 piece pin insulator, and I mean general thumb rule is something like this, that if voltage level is higher, then number of insulate this thing will increase, right, number of insulator will increase, but if, in other way number of pieces will increase, right. So, if 1, 2, 3 so many are there, and particularly for suspension type it is a string, and if it is only for low voltage level, only your 1 piece. Generally thumb rule is that 1 piece means in general it is 11 kV, then 2 piece means 22 kV, 3 piece means 33 kV, like that. So, this is 2 piece, but philosophy everywhere it is remains same. If it is 1 piece, there are 3 piece, then you will see two cemented your coverage here, but if it is single one, sorry 2 1, then only one cemented thing is there, right. So, that means pin screwed into lead line your cement screw formed in the insulator. So, this is actually your pin type insulator, and only thing about this pin type insulator is that if that for pin type insulator, if the your number of this range said increase, I mean voltage level is increased, its cost become higher and higher. Although many cases it is restricted up to 66 kV, but up to 33 kV level its cost is managed, I mean cost is not that high, but if you try to use the your voltage level, then cost of the pin type insulator will be higher, right. So, therefore, the pin type insulator just is supported on a forged steel pin or bolt which is secured to the cross arm of the supporting structure. For any pole or tower, you will see that supporting arm is there. So, the conductor is tied to the insulator on the top group on straight line position and side group in angle position by annual binding wire of the same material or as conductor. As I told, this is the top group and this is the angle group. So, the way this conductor are tied, right. But if the conductor is made of copper, then it should be by same conductor you have to tie, and if it is aluminum, then same aluminum conductor you should use to tie it up, right. So, that means, so and then a lead thimble I showed you is cemented into the insulator body to receive the pin. A pin insulator is shown in figure 2. This is I told you, this is your what you call pin type insulator. So, single piece type pin insulators are used for lower voltages. I showed you the diagram that if you have a single piece, then this one, then this is for lower voltage level. Then your for higher voltages two or more pieces are cemented together to provide sufficient thickness of porcelain and adequate leakage path or creepage path. So, figure 3 shows a single piece insulator, 2 piece or 3 piece. So, this is single piece insulator, this is 2 piece insulator, and this is figure 2 is the single your what you call that 3 piece insulators. It has more, if you want more, then voltage level will be more, right. So, 2 piece and 3 piece insulator just I shown in figure 4, and this is figure 2 actually, figure 2, right. This is actually figure 2, right, respectively. Now, next is, now another thing is for pin type insulator, this one dry and wet arcing distance. So, this side if you look into that, do not see this one, that this side, this is your this is dry, and this is your arcing distance, this is your B and this is C, and this side is wet, this is wet portion, the range set, this is A, B and C, this is your arcing distance. So, in this case figure 5, that is why it says shows dry and wet arcing distances. The flashover voltage for moist and dirty surfaces is less than that of the dry and clean surfaces, right. the total dry arcing distance is the sum of all direct distances through air. So, this is the total dry arcing distance, this one is A, this is B and this is your C, this distance, and this one and the total your what you call this distance is A plus B plus C, and this one your for wet arcing distance is this one is this is A, this is B and this is A plus B, capital A plus capital B plus capital C. So, the total wet arcing distance should be shown by A capital A plus capital B plus capital C in this figure, capital A plus capital B plus capital C. So, the increased size, weight and cost of pin type insulator put a limit to its use above 66 kV. I have written above 66 kV, generally up to 33 kV you will find it is used, and therefore, some cases 66 kV, and therefore, the suspension insulator are used for high voltage work. That means, for high voltage line 66 kV or above you will find all the insulators are suspension type. That means, so many pieces will be there. Before coming to suspension insulator, this is that suspension insulator. You will find any high tension transmission line. If you look at the tower, you will find these are this is the insulator string. There look so many pieces are there, and conductor will be connected at the bottom. This is your vertical position. Horizontal position is also available, and as well as your horizontal connection will be different, and as well as your V connections are there. So, we will come one by one. So, this is your what you call that insulator string, together it called insulator string. So, now we will come to this is the suspension insulator will come. Now, this suspension insulator consists of a number of separate insulator units. So, each one is a separate insulator unit, right, connected with each other by metal links to form a flexible chain or string. They all are connected with a metal link, right, with each other for a flexible chain. It becomes a flexible chain or string, right, and the insulator string is suspended from the cross arm of the support. Suppose you have this thing what you call that tower, and you have the cross arm, and from the cross arm it is suspended. These are suspended. You might have observed in that transmission tower, right. So, the conductor is attached to the lowest unit, and insulator. So, conductor will be it is conductor. Conductor is connected at the bottom, right. And suspension insulator offer the following advantages. It has some advantages. So, what are the advantages? Each unit is designed for operating voltage about 11 kV. So, each unit I told you some thumb rule is there. So, each unit is about 11 kV. So, that a string can be assembled by connecting several units to suit the service voltage and weather condition. So, for example, if I assume the 220 kV line, so roughly your 22 pieces will be there, which will form one string. So, that means it will be very heavy, right. Second thing is, in the case the line is operate on a higher voltage, this is another advantage is there. If in case the line is to operate on a higher voltage in future, to cope with the increasing load, additional units would be introduced to the same string. That means, suppose it was operating at 130 say 2 kV. Now, we want to increase the voltage level. So, in that case this your what you call that option is there, you can connect more string with that, I mean more pieces with that, such that your voltage level can be increased, right. So, that option is there. The additional units would be introduced to the same string. It is possible here, it is possible. Another thing is, in case of damage to one of the units, suppose if out of so many units, suppose one unit is damaged, right. If one unit is damaged, then only the damaged insulator, but not the whole string is replaced by a new one. That means, if one unit is damaged, that you can replace the damaged unit, but not the whole string. This is the another advantage for the suspension insulator. Now, the string is free to swing in any direction, and therefore, the greater flexibility is provided. So, it can swing in any direction, particularly during strong wind or storm, right. The tension in the successive spans are balanced. The lines can therefore be designed for longer span and higher mechanical loading. So, I mean this your what you call that even if there is a your strong wind or storm whatsoever, it will swing, but that distance between the two towers it will be they design it from the how long it should be, and of course another aspect is there, the sag and tension of that we will see later, maybe it will be 4th chapter or 5th chapter, sag and tension, right. But those things therefore be your what you call the tension in the successive span are balanced. So, the lines can therefore be designed for longer span and higher mechanical loading. So, this is the advantages of your what you call the string insulator. So, once this this is a suspension type insulator, and another thing is there is a decreased liability to lightning disturbances if the string is suspended from a metallic supporting structure, which works as a lightning shield for conductor. So, this is another advantage, a great advantage actually. There is a decreased liability to lightning disturbances. I mean, if there is a lightning stroke on the tower, say, if the string is suspended from a metallic supporting structure, which works as a lightning shield for conductor. So, this is another advantage. Since the string is hung from the support, the tower height is to be increased, because the reason is because high voltage line, this insulator, so many pieces are there. So, it is very long, and you have 3-phase line. So, you, that means for each phase there is and in your what you call between your each for 3 phases, 3 such insulators will be there at every tower, right. If it is a your what you call that your single conductor line. So, for in each phase, so that means string is hung from the support, the tower height is to be increased. This is true, tower height will increase. Greater spacing between the conductor is to be provided to allow the for swinging. So, there must be greater spacing between the phase conductors, such that it will allow for swinging. During storm, if you observe, you will see it is to some extent it is swinging, right. The types of suspension are in use are cap and pin type, and second thing is Hewlett or interlink type. These two type are there. The first type is more common, that is cap and pin type is more common. This is actually your cap and pin type, this is more common. Then so, basically a galvanized cast iron or forged steel cap and a galvanized forged steel pin are connected to the porcelain in the cap and pin type your construction. So, the units are joined together either by a ball and socket or clevis pin connection. This is that your suspension pin insulator. This is a pin and clevis type. This is your the same as cement. This is porcelain shell, right. This is the cap, and this is ball and your socket type, right. So, the galvanized cast iron or forged steel cap, this is the cap, forged steel cap and a galvanized forged steel pin are connected to the porcelain in the cap and pin type your construction. The units are joined together either by ball and socket or clevis pin your connection. The pin and clevis type and the ball and socket type connection are shown in figure your 7a and your 7b, right. So, it is 7a, it is pin and clevis type, and it is the ball and socket type. At this there is a video class, and if demonstration is required, then one has to go to the substation. Just so many open insulators are there. I mean, those who will take these courses, maybe in your if you have a lab, particularly high voltage lab, you may have this insulator thing, and there you can observe all these things must be there. And second thing is the interlink type unit, that is this figure. This is actually interlink type insulator. Have a look, just this one interlink type. It employs porcelain having 2 curved channels with planes at right angles to each other. You have this 2 curved your what you call that 2 curved channels, and it is there is a U shape here. This is a U shaped here. So, U shaped level covers your steel links pass through these channels and serve to connect the units. This U shape link is there, right. So, pass through these channels and serve to connect the units. So, this is actually interlink type, but in what will happen that interlink type unit, it employs porcelain having two curved channels are there. So, there is insulating material between this curved channel, it will be there will be highly electrical stress on this, right. So, that is another disadvantage of this one, that between these two, that insulator material will be there and it will be highly stressed. So, therefore, the interlink type insulator is mechanically stronger than the cap and pin type, that is correct, but the metal links continue to support the line if the porcelain between the links breaks, thus the supply is not interrupted. So, metal links actually continue to support the line if the porcelain between the links break, thus the supply is not interrupted. This is some of the your advantages of this your what you call that this kind of insulator. So, but interlink type insulator suffers from the disadvantage that the porcelain between the link is highly stressed electrically and therefore, its puncture strength is lesser as compared to other types. That means, in between that in porcelain insulator is there will be highly electrical stress, right. So, that means, the puncture strength is lesser as compared to other type of insulator. So, these are the your some kind of configuration of the insulator, and the metal links and between each pieces that there will be metal link to support the line if the porcelain between the links break. If porcelain breaks also, later you can replace, but question is that it will support the line, right. So, this is the advantage. So, thank you, we will come back again.